I'm Rob Brooks. We're going to talk about shadowing. Shadowing from A to Z, which is a bit of an inside joke. A to Z refers to John Andruszkiewicz, who is, as it says, a longtime shadowing project leader and a real good mentor, real good guy. So how many people here have ever used shadowing? All right, and how many people are still using shadowing? So it seems like we have a fair amount of people here who haven't used shadowing. So this presentation, I think, should be pretty interesting to those of you who've never used shadowing, because I attempt to start from the beginning. We move pretty quickly, but the slides have a pretty good detail, and you'll all be getting the slides after the boot camp. And so there's good stuff in the review afterward. For those of you that have used shadowing, have you ever used Host-Based Minimerge? Okay, good, thank you. We appreciate that. As always, the documentation for this old software is really, really good. The doc writers back in the day with Compaq and Hewlett-Packard were embedded with us engineers. They would go to all the product design meetings, so they really understood this stuff well. Shadowing can be a little tricky and confusing. The shadowing guide is wonderful. And in fact, some of the stuff I've just lifted directly out of there because I realized I couldn't write it any better or any clearer. So I really suggest looking at the documentation, and the DCL dictionary, especially for set and show shadow, is also very helpful. The online help is good too, but the documentation is real good, especially with some of the oddities when it comes to host-based mini-merge configuration. So we're going to go over a bunch of things in the next 50 minutes. I don't know that we'll actually get to everything, but once again, you'll get the slides afterward. And at the very end, some shadowing internals, again, if we have time. So some vocabulary. I'm not going to read the slides. You guys can read it. I'll just stand here and let you read it. But just a few things, few terms will come up over the course of the next 50 minutes. If you got questions at any time, just fire them out. Well, I'd like to deal with them right in the middle of things. And all you other experienced people, if you want to chime in too, go ahead, because it's the more the merrier. So what is shadowing? Well, strictly speaking, we're attempting to provide some redundancy via RAID 1, which is in other areas typically called mirroring. We call it shadowing. And there's a little background there about how we got where we are today. The first implementation was not host-based, it was controller-based, which was very good in some respects because, well, hardware is fast. But there's also limitations, specifically geographically. And so that's among the things that phase 2 shadowing gave us, is the ability to have disaster-tolerant clusters in different locations. Two reasons: redundancy and performance. Performance one is a little tricky, and it's probably not going to be in use a lot unless you've got a disaster-tolerant cluster where you've got local and remote disks. But in that case, you can always make sure you're reading from the local member. If you've got two members split in two different locations, you always want to read from the local member rather than going across, the distant line. Licensing. Need a license for shadowing. Depending upon whether you've got the HOE or VOE license, if you've got HAOE, VolShad's part of that, so it's not an issue. If you've got VOE, you need to get the VolShad license. And a little licensing inside stuff here is you actually want to see how those OE license mechanisms work. That show license command will give you a lot of information. So what we're looking at here, this happens to be an x86 virtual machine, and that's showing we've got HAOE license on the system, and it's showing all the things that are under HAOE. After that, we also see the entire hierarchy of VOE, because the way things are split up, for HAOE, you get those added 6 things, availability managed through the cluster client, but you also get BOE. In any event, if you ever cared about how licensing worked, show license / hierarchy / OE / full give you a lot of the details. Not really a shadowing specific thing, but shadowing does use licensing. Sysgen. There is some sysgen work to be done using shadowing. The important ones are bolded. Shadowing must be set to 2 for phase 2 shadowing. That's the only one you really need. If you want to shadow your system disk, you need to set both shadow says unit to whatever value, and 0 can be a valid number, but the specific one is shadow sysdisk must be non-zero. And you can set it to any non-zero value, but I strongly suggest you just set it to 1, because that parameter is frequently used for debugging, where we've got a bunch of stuff in there. When we may tell you to set it to a seemingly odd value, but that will turn on some tracing. That if we're having some trouble and we want to collect some information, we'll tell you to set shadow system disk to some strange value. So in general, just leave it at 1. And there's some other parameters with shadowing that you will likely never touch. And please don't touch shadow _ D1 through D5, because once again, those are ours to use for debugging, and there are some of those in the actual shipping driver that we'll use to enable different behavior if something strange is happening. All right, so let's get started with shadowing and how we actually use it. Not surprisingly, you need to mount some devices to create a shadow set. So in this case, we are mounting 2 members into a shadow set. It's already been formed. It's got a valid file system on both members. And you'll see the mount command is relatively straightforward. The key qualifier is the /shadow command, where you list the members you would like to mount, followed by the volume label. And there it tells us it's successfully mounted them. Because those members had been cleanly dismounted at the same time, there's no copy needed. And we'll get into copies and merges later on. But again, if you have any questions, like Nick.
So it's not a question, it's just a comment on the previous slide. Your allocation class has to be non-zero.
Oh, very good. Thank you. Thank you for pointing that out. That's one of those things you take for granted, but you're right. Allo class must be non-zero. If it's not, you will be told pretty quickly when you try to mount a shadow set that allo class must be non-zero. Thank you for pointing that out. Second example shows a kind of a shortcut here, where you don't even need to specify the members. All you need to do is specify the virtual unit device, which is DSA40, and its volume level. That only works because the shadow set's already mounted somewhere in the cluster, and the unit and the shadow set had been mounted on this node already. So DSA40 existed on this node. It just happened to have been dismounted at the time. If you try omitting the member list and it's not mounted, you are told you can't do that. So this is an example where we're going to force a copy. A copy is when you've got members that aren't in sync. And so we're adding a second member, and shadowing can tell, and we can a little later talk how shadowing can tell that a member is not in sync with, the members are not in sync. So in this case, what happens is, another thing. When you're doing operations with shadowing, it's also a good idea to have opcom enabled, because you will frequently get useful information through opcom with shadowing, especially if something goes awry. But here it's telling us when we mount the second member to the shadow set, it's telling us that it's beginning a copy operation. Not a problem. I mean, that's what we want to see.
Just by the order.
I'm sorry?
It does it just according to the order you add them to the set.
Correct. The order is not relevant.
No. When you added DJA 238 and then 218, it copies from which to which, from the first to the second.
Okay, so what happens is shadowing can tell which is the source member, which is the target member. It can, yes, it can, because you're adding, when it knows when you're adding the second member, that's going to be requiring the copy to it, because the shadow set was formed such that only the first member DGA 238 was added. That's so.
So that's what I'm saying. So first unit was there as
Correct.
first.
Oh, okay. I'm sorry. I was thinking back to this earlier slide when I was listing the members there.
No.
Okay.
I mean, the one you mounted first becomes the source.
Correct. Yes. Yes.
If you got the wrong one, and they were severed, did that work on one?
If that you'd have a problem. No, because I mean the once you've mounted the single member shadow set, that is the source member, and it only goes in one direction. It goes from source to new member. Yeah, you're stuck.
Not a separate.
That's it.
Like anything.
No, it goes from LBN 0 to LBN max block -1. It doesn't wipe anything out first. It just goes. And we'll get into shadows versus merges and why copies are much faster than merges, etc. You have a question, Keith?
It probably upstates the
generation number.
Yeah,
Yes. Well, we get yes, it does. That's exactly what it does. So dismounting. So what's going on here? The first dismount command, we're actually dismounting the one we just previously mounted on the slide, and we're ending the copy, and it's telling us that yes, the copy is ended, and we've removed both members from the shadow set. In this case, we're not dismounting just a single member; we're dismounting the entire shadow set. Once again, OpCom gives you pretty good detail as to what's going on. You're creating a shadow set from scratch. The /shad qualifier to the initialization command can save a lot of time because it'll make both members identical in terms of shadow and generation numbers. And so when you're going to mount, it mounts them both. There's no copy needed. Now, in this case, there's also no data. You've got a clean file system. But the point is it doesn't require a copy. You can also use the /erase command on the initialization. That'll take a lot longer because it's literally going to write zeros over the entire device. The benefit of doing that at that time is that if you ever needed a merge, most of the disk would actually be identical at that point because you've erased everything, so you've got a bunch of zeros. And when merges take place, it actually does comparisons. And then if it changes, if there is a difference, then it does actually pick a source and go and copy from the source to the target. But the point is, if you've got time, using erase at the time of initialization is good because it might save you some time later for merges that are needed. All right, so this is a complaint of mine, and I recognize that the /cluster qualifier is supported and documented for use. I think there are problems that I can't solve. It works a lot of the time. It'll probably work 90% of the time. But when it doesn't work that 10% of the time, the crash lands on my desk, and it doesn't make me happy. And it shouldn't happen because there is at least one bug, if not more, somewhere in the mount and shadowing code. And it's driven me nuts trying to find it. And as it says, I've been picking at it for 20 years, and I can't find it. But as I said, plenty of people use it. It's documented for a reason. I don't use it because I don't trust it. But if you're using it and you're never having a problem, continue using it. But it's just a warning that there's a timing problem, with synchronization, and it's real tricky. And I don't know, but Keith, do you have any?
I've run across a lot of people that think if I'm mounting a disk in a cluster environment, I have to include this cluster.
Yeah,
but that's not the case. /cluster means do a mount /system on the local node and then do a mount /system on each of the other nodes in the cluster.
Yeah.
So is the solution to do individual mount /system on each node then?
Yeah, and you can get into sysman, do a set environment /cluster, and issue command that way too, and that will synchronize things because that'll just do one at a time. Cluster just sprays the stuff, and they all try to do it at the same time, and they wind up running into each other. So anyway, it's documented. So this is my personal preference, but it's supported.
So one of the things that I have seen using this is if you get the device available on a remote mount, so you get the remote mount available and it says device unavailable. That's what we observe occasionally using this. Yeah.
Okay. All right. Set shadow can do a lot of things, and we're going to cover the most interesting ones here. I mean, once again, documentation covers this in much better detail than I can in the few minutes here. If you use host-based minimerge, you are quite familiar with the set shadow command because that's the way you define HBMM policies that describe how the recovery will work. But you can also do a few other things. And one of the more interesting ones is the demand merge qualifier, which forces a merge on a shadow set. You might say, well, why do you want to do that? And the primary reason that we put that command was for engineering testing, because when we were developing host-based mini-merge, we wanted to continually force merges to see if things were actually working. But it actually does make sense for customers to use it too, especially once you've set up your host-based mini-merge policies to make sure that things are actually going to work as you expect. And we'll get into the host-based mini-merge policies later, and picking nodes on which you want the merge to happen and selecting the nodes and priorities. But that would be a mechanism to ensure yourself that your mini-merge policy makes sense. Show shadow shows you a lot of information about the shadow set. And the full qualifier, which I will show in subsequent slides, output from show shadow and with the full. Full is primarily for me because there's a lot of internal stuff in there. But it's rather than using SDA or one of the other tools we have, it's a nice quick way to get some useful information for us. So here's a show shadow command. Nothing real interesting here. This shadow set has host-based mini-merge enabled. Its policy is listed below. But some of the stuff in the middle above the policy can be useful. Most of those are probably all defaults, because in this case, I haven't really changed anything. And the defaults, for the most part, will probably work pretty well. And we'll get into some of the things you might want to change. But the key thing is, and looking at this, really is the fact that at the top, the virtual unit state is steady state, which means that there's nothing interesting going on. There's no copy or merge or anything like that happening, so that everything's in good shape. You've got two members there. They're healthy. And again, once again, you've got the host-based mini-merge policy, which we'll go into much more detail in a few slides. So this is the show shad / full. And I've put in bold all of the stuff that you get with full. And if a lot of the terminology is kind of strange to you, it's because it's really just kind of replication of internal stuff that we use. There may be some time, however, if we're troubleshooting a problem with you folks, we might ask you to provide that just to give us a full sense of what's going on. Shadow server. That's a process you'll see on your system if you are running shadowing. Initially, the shadow server process was an optional piece of shadowing that was only used or only existed when copies and merges were taking place. About 20 plus years ago, when we did the work for host-based mini-merge, we changed things to require the shadow server process to be involved in any shadow set mount, even if host-based mini-merge wasn't in use, because we don't know at the time what's going on, and we need to use the shadow server process to query other nodes in the cluster to ensure that what you're trying to do will actually work on all nodes in the cluster. Because there's certain things like, well, host-based mini-merge, which 20 years ago when we were developing it might not have been supported on an older version or a VAX or something like that. Anyway, that's the shadow server process. And it's real important. Is the last bullet explains what happens if you can't start the shadow server process. The system will pull the plug, which will probably never happen. There are many places in the shadow server startup code where it looks to pull the plug, but those are very, very weird edge conditions, things that you should never see. But just in case we don't want to start, we won't let the system go up without that process. So talked about shadowing the system disk a little earlier, as in terms of sysgen params, and I put my plea there in bold. Please always use mod params and autogen. Please don't just set the parameter using sysgen and doing write cur, write active. It makes everyone's life a lot easier if you keep mod params up to date. And that's really not just a shadowing thing. That's just a system management thing. But please do it because it makes everyone's life a lot happier. A newish addition to get SYI is the boot device item code in case you forget which member you've actually booted from, because the way shadowing works is it'll boot from one specific member and then automatically add the other subsequent members, assuming that they were in the shadow set before the system went down, because it keeps track of the membership on the disk itself. So it'll pull out those devices as the system is booting and add them. But for a multi-member shadow set, sometimes you forget which one you actually booted from. So that's what the boot device item code is. And that's been there for 20 plus years. I'm not even sure it's even documented. It should have been. But so in this example below, the show device shows it's a 2-member shadow set. Now in this case, it's kind of obvious which one you booted from because you couldn't have booted from the copy target. So you know that it's going to have to be DKA 200, and the item code does in fact confirm that we did boot from DKA 200. Copy versus merge. Now we're getting into the confusing stuff. Go ahead, Keith.
What happens if you remove the device you booted from the shadow set?
It should still indicate that that was the boot device, because I think it looks at exec$gl boot UCB or something like that. So that wouldn't be changed by the shadow set consistency. Okay. Anyway, copy versus merge. It says there, copy simply duplicates the data from source to target, and it usually will happen in a response to the mount command. Merges typically take place when something bad has happened. Either another node in the system has crashed, or you've lost contact with a disk, fiber channel cable, or older SCSI cable, something like that. Copies are a lot faster than merges, and it explains their why.
They're changing while it's merging.
Oh yeah, no, it's okay. In fact, we'll there's a later slide, maybe the next slide, or maybe some slides later, we'll discuss the concept of the merge fence and IO below, above, and below the merge fence, and how it can tell when things are changing.
Might be behind the curve with merge, but my understanding of merge was if there was an issue, it would pick one as the master, and it would simply do the replication, but it would replicate from the, not where it was copying from, but the other. It was a device error trying to remove that. So that's probably not explaining all about it. It was all geared towards hardware issues where there was something bad on the disk, so like a bad block, something so it couldn't read the data, so it used it for all the sources.
So, okay, I understand what you said, and I think what you said is largely accurate, but was there a question in there? Just one thing?
No.
Okay, no, I believe what you largely described is correct. Okay. Yes, yeah. An interesting thing is, again, when you're merging, shadowing guarantees consistency. It doesn't necessarily guarantee correctness. Yeah. And that's kind of a weird, subtle distinction.
Grade 1, after all.
But shadowing doesn't, when it's merging, it's not necessarily guaranteeing that it's taking the newest copy of, it doesn't really know which one is new or older. It's just guaranteeing that they are the same. And the only time that might be a potential issue is if a system crashed, IO was in flight, got to one member, didn't get to the other member. Well, when the merging takes place, it may merge such that the IO did take place on both members, or it may merge such that it gets wiped out on the one that did take place. And there's really no way to bias which one will be used. Sure. No, go ahead. Mhm. Oh yes, yes. Oh yes, and we'll get to that. Yeah, we'll get to that in excruciating detail. So anyway,
But if the disk utilized,
I'm sorry.
but if a disk is utilized not a lot, just small part of the disk is actually occupied, and it has been zeroed, merge can be fast.
That's correct. In that case, yes, because there won't be much changing going on. Yes, you're absolutely right. So anyway, copies. Full copy pretty much just goes from the beginning to the end of the disk and replicates the data. Mini copy uses a bitmap, and that's why it's typically a lot faster. We'll get into those details. So mini copy, as I said on the previous slide, uses a bitmap. The bitmap is typically created when you're dismounting one member from a multi-member set. So in this example, we have a 2-member set, and we're pulling out one member, and you might want to do this to back up a member, because when you pull it out of the set, there's no IO going on. You don't have any IOs in flight, so you've got a consistent version of the data. So you pull the member out, you say /policy equal mini copy. And what that will do is, as the opcom tells us, it pulls the member out. And if you look at the output from show device /bitmap, it'll show us that there's 2 bitmaps now for that virtual unit. And in bold, you can see that the first bitmap is a mini copy bitmap. And then there's also a mini merge bitmap, because I always have mini merge enabled on all my shadow sets. So in this case, we now have a mini copy bitmap. So now we're going to pop the member back into the set. Once again with the mount command, specifying the member that we're adding, which is the one we moved, which is DGA 140. And then once again using the policy equal mini copy qualifier. And what that does is it says, if you can't start a mini copy, don't add the member. Only do the mount if you can tell me that a mini copy will take place. And so you can see in the second mount message there, it's telling us that it is in fact being added with a mini copy operation. That's good. And then you can see from opcom once again that it's actually beginning the copy operation. Now the opcom message doesn't say mini copy, because opcom at that point there's no way to tell it's a mini copy, but mount knows. In any event, so opcom tells us it's beginning the copy operation, and opcom tells us when it's completed it. In this case, since I immediately did the removal and the remount, the actual copy took place in less than 1/10 of a second, because there was no data delay.
127 blocks.
Yeah, there just wasn't much going on. So, well, the IO size, it says on the beginning copy, it does say the IO size is 127. You're always going to see that. It's always 127 for a copy or a merge. Now, in this case,
It's size of one.
Pardon?
Exchange size. 127 is not the size of what should be copied.
No, that's the IO size of every IO that it's going to do.
IO.
Yes. Yeah. Anyway, so that's a mini copy. Okay, so here's some information about merging. So go ahead and read that for a bit. And this is right out of the manual. And once again, if you've got any questions about that, go ahead and ask. So full merge versus mini merge. Just like full copy versus mini copy, it merges from the beginning of the disk to the end of the disk. And just like mini copy, mini merge uses a bitmap. And as we discussed earlier, you can use set shad/demand merge to force a merge, and it'll force whatever merge is required on the virtual unit. If there's no bitmap, you'll get a full merge. If there's a viable bitmap, you'll get a mini merge. All right, host-based mini merge. Yeah, the fourth bullet is interesting because we actually did start an engineering effort to try to add hardware mini merging to the HSG 80 in the early 2000s. And that was sort of a controversial thing because just getting storage engineering in Colorado to do that was a difficult thing. And they finally said, all right, fine, we'll do it. But this is the last time we're going to do it. For any new controller, we're not going to do it. So an effort was made to start it, but it was not a great engineering effort, and it wasn't going well. And about a year and a half into that project, I got added to it just to take a look at it. And within a week, I went to like the senior people in VMS engineering and said, this isn't going to work. This hardware thing, it's too much of a mess. And so thus host-based mini merge was born out of that failed engineering effort. And the benefit of host-based mini merge is, among the benefits, is that it doesn't require any hardware. It'll work on any system with any type of device, whereas the hardware solutions were specific to one controller or to a series of controllers. So this has eliminated that requirement. Another important thing is when we started doing the mini merge work was we weren't really sure how much memory all these bitmaps were going to take. Kind of worried about that. You can see, however, that on this system, I've got the last line there shows I've got 67 shadow sets on my system, and it's not even using 4 megs of memory. So the memory consumption just is virtually non-existent. And you've heard me speak a little earlier about host-based mini merge policies. And the policy is the key method that one uses to define how the mini merge bitmaps will be allocated across the cluster and how the operations will work with them. And there's a lot of variables and things that you can vary, and we'll get to those elements. One of the more interesting ones is the third bullet, is the reset threshold. And that's one of those things where, the larger the threshold, which means the more dirtiness you might have in the bitmap, the longer it might take to merge. So if you've got a bitmap with only a handful of blocks changed, you'll be able to merge that quickly. If you've got a bitmap with, thousands of blocks, it could take a lot longer. When we started this work, we had no idea how quickly this stuff would happen. So we started with an initial threshold of like 50,000 blocks. And the first time we did a merge, it took like less than a second. Oh, okay. Well, I guess we can up the limit then. And so right now, we upped the default from 50,000 to 1 million. We increased by 20 times. And at this point, we should probably increase it another 10 times because even if you're merging 1,000 blocks, it happens quickly. But again, that's one of those things where we set our defaults and we don't ever go back and reassess whether or not we should up them. But I do think it's probably one that we need to up. So the original, I'm sorry?
Maybe a factor of a fraction of the disk size.
Sure, it makes the code a lot easier not have to do that, but sure, that may be a reasonable thing to do. So when host-based mini merge was first done, the policy consisted of those 3 required elements. Sometime later, 2 optional elements were added: the multi-use and dismount. For anyone that's using HBMM, have you ever used the multi-use or dismount stuff? Okay.
That's your point. That's yours.
Sure, yeah. So the first bullet item says the policy creation syntax is complex. And for that, you can blame me. I am the one that set out the DCL syntax for that. And I agree that it's complex. But it's because it's flexible. There's a lot of flexibility built in, and it got really tricky to. There's a balance between usability and functionality, and we sort of voted for functionality on the theory that over time people will understand it, and you'll typically have these things in DCL command procedures, so you won't need to remember it, and it's almost like a set it and forget it kind of thing. And later on, we'll see some incredibly simple policies. In fact, that's the one that I use because I don't want to do the syntax. And as it turns out, and it says in the first bullet item, the help set shadow examples has 8 examples of policies. So if you are trying to understand how to do a policy, the online help will give you a lot of good examples because we really made every effort to try to make this as understandable as possible. And I could stand here and attempt to read all that, and you would probably fall asleep, so I'm not going to do that. But the key things are, I was taking the first example. In the master list element, what you do is you have a list of the potential nodes in your cluster on which you would want to have the bitmaps created. A reason why you might want to only specify a subset of the nodes is that if, let's say, you've got some alphas and some titaniums in your cluster, and you're right, and these are all on fiber channel. Well, fiber channel adapters on titanium are far faster than they are in alphas. So you might want to bias all of your mini merging to be taking place on the titaniums because it'll complete a lot quicker. I mean, we have 4, 8, and 16 gigabit per second adapters on titanium, and you only have at best 2 gigabit adapters per second on alpha. So that's the reason why you might limit your nodes. Otherwise, you can have a master list of asterisk, which means all nodes in the cluster to make it nice and easy. And you might also want to limit, for whatever reason, the nodes, the number of bitmaps you would have. Although at this point, you probably wouldn't want to do that. But at the time when we did that, we put in the limit. But you are limited to only 6. I'm sorry, I didn't actually list that there. You can have a total of 6 bitmaps for any one shadow set. And then, of course, the reset threshold, which we discussed earlier. But again, if you are happy with the default of 1 million, you don't even need to specify the reset threshold in a policy. Another thing you can do is the concept of named policies. If you don't want to apply a policy specifically to a shadow set, if you have a policy that you like generically, that you want to apply to a set of shadow sets, you can create a named policy, and you can apply that to multiple shadow sets. And the last DCL line there assigns a named policy to a shadow set. And once again, I recognize some of the stuff is confusing if you've never seen it before. So if you have any questions now, I'd be happy to entertain them. But the documentation does explain this pretty well. So for the named policies, we actually have a couple special ones. And my favorite is the default policy, because this is a pretty much set it and forget it. You create a single policy, and that policy by default would get applied to any shadow set that you're mounting. The policy is applied at the time of mount. So if you define a default policy after a shadow set has been mounted, it won't get allocated. It won't get allocated, applied to it. The no default policy is the inverse of default. If you're saying, yeah, I don't really want this policy to, I don't want this shadow set to merge. I don't know why you would do that. But if you ever wanted to prevent a shadow set from ever having a mini merge policy, no default. I'm not sure if anyone's ever used it. I know I haven't.
It could be helpful in the case of a node that has a private shadow set for its patient swap file disks.
Sure. Yeah, that's a good point. Yeah. So applying the policy is one thing, which is good, but you need to explicitly enable HVMM even after the policy is there. So that's another use of the set shadow command. And policy can be removed by deleting the policy. So once again, show shad, taking a look at the HBMM policy, taking show dev bitmap, once again shows us, in this case, the policy specifies up to 4 nodes, but if we look at the bitmaps, we only see 2, and that's because for whatever reason at this time, that shadow set is only mounted on those 2 nodes. So we're going to go to the next slide has the example of one of the nodes where it's not mounted. Then we mount it on a node, and then you see there's a 3rd bitmap on node root 2. And that was added automatically because there's the policy applied to the shadow set. It knows to start the bitmap up as soon as it's mounted because root 2 was one of the nodes listed in the policy. And once again, the demand merge qualifier shows us starting a mini merge and rapidly completing the mini merge. Once again, there's probably little IOs having taken place when the bitmap was dirty. So once again, op column tells you when it starts and when it ends. There are times when you want to bias the recovery operations, which are copies and merges. And there may be some shadow sets that are more important than others. And you would want those to either copy or merge before other shadow sets. That's what the priority is used for. And that's one of those things that, again, you can specify with the set shadow command if you want to assign a priority. Priorities, as it says, go from 0 to 10,000. Default is 5,000. And if you want to see what your priorities are, the set show shad by priority qualifier will give you a list of all the shadow sets with their priorities. Now, again, in my case, I'm not too worried about the priorities, so I leave them all at default. But if you've got really important devices that must merge or copy before all others, use the priority.
So, question: are those priorities used at all in terms of reading?
No. There is the read cost mechanism that you can use to bias which member is read. But the priority is only used to determine recovery operations. All right, so if you've fallen asleep and didn't listen to anything I've said for the last 40 minutes, that cheat sheet pretty much tells you everything you need to know.
So, sorry, just on your previous slide. So we have split site clusters, and one of the techniques we use to speed up our copies to the remote system is to actually disable shadowing on the system which is already up. So the booting system performs the reads rather than the system that's already up forming the writes, because the remote writes are more costly than the reads. That's one of the techniques we use to speed up copies.
One other thing I didn't point out in here is the sysgen param shadow max copy. If you have a node where you don't want copies to take place at all, if it's a slower node, etc., set shadow max copy to 0. The default, I think, is 4. And if you've got a faster node that you really want more things to take place, ratchet up shadow max copy to a higher value. So that's also another way to kind of bias or prioritize what system will actually do the recovery operations. Anyway, getting back to the cheat sheet. That's a quick summary of much of what I just discussed. The very bottom one is kind of like one of those, is the set it and forget it HBMM policy that I use, which is to say, let any node hold a master bitmap, max of 6, which is the most you can have, and that's the default policy. And so that will apply to all shadow sets. And so that's what I do when I start up my system. And that's the sort of thing that just works. So we talked about some shadowy internal stuff. And again, This stuff is right out of the shadowing manual, but this describes a little bit of how shadowing actually works. And the key thing here is the shadowing generation number that's stored in the SCB. That's the mechanism that determines when you're comparing members, which is newer, is a copy needed, is this older, when did it get dismounted? Shadowing generation is the significant thing. And here's some information in the storage control block. And these are various values that are used when trying to determine the health of a shadow set. And once again, the generation number, but the various statuses that we check within VMS itself to try to determine what's going on with the shadow set. So HVMM policies, they're stored in cluster-wide logical names. That's how they get disseminated across the cluster. And there's a couple specific logical name tables that are cluster-wide where that takes place. Here we're looking at the device policy table, which lists all the policies that are applied to specific shadow sets. And you'll see the show log command will show you that information, and you must specify the actual name of the table where the logical name resides. And we use, for the policies, you can see the various elements within the logical name. One interesting thing when we were developing this code is you're probably aware that there's a limit of 128 logical name translations for a logical name. The interesting thing is you could define any number of them. You can define 1,000. The problem is you can only return the first 128. But there's nothing that ever said, hey, you're defining stuff that you're never going to pull. And the problem is there's also another element to the Translate Logical Name System service that returns the number of translations there are. And it was dutifully returning like 1,000. But anything above 129, you're getting an error back. And this is like 2003. And so this has probably been going on for, at that point, 20 plus years. So you find broken stuff sometimes in VMS. And that was a weird edge condition. Anyway, so that's the policy table, device policy table. Then there's also the named policy table, which is where the named policies are stored. Then there's also within SDA the show device / bitmap command. We saw the show device / bitmap command from DCL. We also have something similar in SDA. This is one of my more proud moments. I spent when I was picking through a problem in the right bitmap technology, I spent days decoding hexadecimal addresses and offsets trying to figure out what was going on. And, it works, but it just takes forever. And I said, all right, I'm never doing this again. So I wrote that part of SDA to decode 4 or 5 different data structures and to make them in a more easily readable mechanism. And, again, you've got locked value blocks. You've got locks, you've got locked value blocks. You've got a lot of detail there. And my eyes were bleary after having figured that out, paper and pencil and, hexadecimal math. So anyway, that's SDA. And this is various bitmap related stuff. And that's it.
So how many members can you have maximum?
6. And that's a relatively recent, in the last 18-year edition. We had been 3. I think in 2006 or 7, it went up to 6.
So if you take a 2-member service, how does it, is it still reading based on depth? Or what other factors? Which member would read?
By default, it round robins goes from one to the other.
Robin?
Yeah. Well, it'll also look at Q depth too, but assuming the Q depth are identical like 0, it will Yeah, it'll round them. But yes, it does look at Q depth.
The other factor is read cost.
Yeah, sure. Yes, yeah, the read costs also.
From 2 to 6 members. Is your performance suffer?
Maybe. I mean, it really depends on your. It really. Yeah. See, the thing. It really depends on your I/O load. I mean, there's an earlier slide I think that said, many applications are 80% read, 20% write. So yes, there will be a write penalty. Although when shadowing does its writes, it does them asynchronously. It doesn't do one. It fires them out and then waits for the statuses to come back. And then once the success status is returned on all the members, then it returns the I/O. But it doesn't wait. It doesn't do one, get the status, do a second, get the status. So yes, it could, but your mileage may vary.
Yeah, so for performance, when you've got split write plus reset the read cost per site so that the local system knows to read local, prefer the local disk to the remote disk. So manipulating the command to make it read the remote system. Otherwise, it might read from that place.
An area where performance might hurt going to 6 is with host-based mini-merge, when you're updating all the bitmaps on the nodes, that is done serially. And an attempt was made to do that asynchronously, and it failed miserably. And so that's not as much 6 members, that is much how many bitmaps do you have? And if you've got 6 bitmaps, it's going to take more time than 2 bitmaps. So that's not really a number of member issue, but that's really just more of a generic shadowing issue and with HBMM.
Should be what's the switch? 2 seems pretty well done. Is 3 better than 4? Or is 4 better than 2?
Well, it really depends on what you're trying to accomplish. I mean, a lot of people would say 3 is far better than 2 because you can pop a third member out, back it up, but you still have a 2-member shadow set giving you the redundancy. And so, I would say in that case, depending upon your operational procedures, 3 is better than 2. There may be a reason to have, well, Keith, have you ever used a 6-member shadow set?
I can imagine a 3-site disaster.
Sure, right. But for a single site, it would be difficult to justify more than 3 members, I would think.
And 2's ordering one unsafe.
Well, and the thing is, hardware today is really reliable.
It is.
See, that's the thing, especially with fiber channel, in multipath, unless your entire HBA goes out or your entire storage array goes out, in which case you've got other issues. But devices themselves are pretty rock solid. I've got an older MSA 2040, which is technically not even supported anymore. But in my systems, I've got a pool of RAID 5 volumes, and then I create my LUNs out of RAID 5. So the RAID 5 at the hardware level, right? I present the LUN to my VMS systems, and then I shadow what are effectively 2 RAID 5 LUNs. So I've got all kind of redundancy.
Host-based.
Yes, the host-based, yeah.
And for host-based versus 10-based, say, do people even do that anymore on the MSA itself? Or just rely on it?
I think some people do. Again, it really depends on your enterprise-wide storage plan, because in many cases, VMS is such a small part of stuff, and they're used to doing hardware mirroring, across controllers. So if that's the case, they might not want to treat VMS any differently than the other systems.
Now, on x86, they simply, if to use VSI recommend server, right? They just offer hardware controller to do the mirroring.
Sure.
No,
yeah.
not just mirroring, RAID.
Yeah.
So you just transparent to you.
To VMS, yes. If you're mirroring it beneath us, we just see a LUN. We don't really know what's going on there, and we don't care, right?
Yeah.
We can't know. So.
Thank you very much.
Thank you.